we will take questions at the end if we have time. So thank you. Take it away.
Hello. Hello, and I'm super excited to talk about my favorite open source Python package for machine learning applications, MLFlow. But before I start talking about the details of the package, I want to talk about trust and why I've named this presentation Trustfall. So many of us might know Theranos, but for those of us who don't, it's a now defunct biotech startup that had really lofty goals of disrupting the medical industry by creating a blood test that you could just do with a prick of blood. It had a lot of visions, and it really quickly drew in investors to fund and create high valuation for the product. So over time, it gained a lot of interest, and at its peak in 2014, it was valued at almost $10 billion. But when you go high, they come after you. And the Wall Street Journal found out that they didn't really have data to back up their claims. They looked more into what Theranos did and tried to see if the metrics really aligned with the story that they were telling people. And it turns out it didn't. And just like that, their valuation dropped to zero, and it is now a defunct company. But why am I telling you this story? Why does it matter? Well, in the age of AI and machine learning, when a lot of companies are trying to figure out how to integrate AI into their systems, I think that this story and this lesson is really important. And the idea is that building trust through metrics is critical, not just for documentation, but for the success of the overall product and the long-term vision of your company, your brand, whatever it is you're looking into. So how can we build trust in our machine learning applications? Well, the first thing to do is document. So you're going to need to document all of the findings, the overall process that you've used, the model that you've built. And the second is, just like all scientific experiments, you want to ensure that your end result is reproducible. That if somebody were to try to audit your machine learning model, they'd be able to follow exactly what you did and get relatively similar results within a certain range, since you won't get the same exact metrics every single time necessarily. And the last is transparency. So can somebody understand the overall process that you took in order to get to your final AI model? Can they track from start to finish what your thought process was and what were the other things that you were including alongside your metrics and the performance that you put in your documentation? Does it tell a story that makes sense? So we've talked about why we need to build trust and how we build trust, and now is the exciting part, which is what tool can we use to build that trust? So a lot of machine learning applications, they have three components. They have the code, which portrays the data pipeline and the actual machine learning model. And then they also have the input data, so the things that you're feeding in order to train the AI to understand the patterns. The third part is often a part that tends to be neglected until the very end, but is just as important, which is your performance metrics. And that is where MLFlow really helps. MLFlow automates portions of your metric tracking for your machine learning applications along the way. So you don't have to scurry last minute trying to figure out how to wrap it all neatly into a documentation that somehow gives the story of your performance at the end of the project. It does this by providing organization tools that you don't have to worry about or manage or design on your own. So it gives you an artifact storage, right? That's called ML runs. So it's kind of like a directory that's organized in a specific way, which I'll show you next. And then it also gives you a SQLite database that you can use to store the different nuances that go into each trial that you're running for your machine learning application. So the artifact storage looks like this. You can hook it up to whatever you want if you're using S3 or something else, but off the bat, it just kind of creates a local folder within your project. And it organizes it in a way that is grouped by experiments. So you can kind of, maybe you're testing a certain feature, or maybe you're testing, like different algorithms. However you want to group your things, it'll be called experiments, and every single iteration or trial that you run on your AI will be called run and have its own, automatically assigned hash value. And then the second thing is there is the database, like I mentioned. And if you want, you can hook it up to your own like Postgres database, your MySQL database. It doesn't really matter. But the nice part is that it comes up with the schema for all of these tables that are listed here automatically, so you don't have to write code and worry about how to manage your own storage. It does it all under the hood. But my favorite part is the fact that it comes with a really easy to understand UI, which you can use to talk about your metrics and your findings within your team, and then also later on as you are presenting it to maybe non-technical people or clients, or if you want to use it to demonstrate research findings, whatever it is. It'll basically put down your metrics, your parameters that went into your machine learning model, as well as any tags that you've chosen to keep track of. And the way that it works is you just import MLFlow into your Python application and set a tracking URI. So, whatever server you're using to kind of track all of your experiment data. So this is just a local host for right now. And then also you can set your experiment. So with just those 2 lines, you can start using MLFlow in your Python project, and it'll know how to organize the experiment runs and where to put them in the database. Then you just put your ML code in your model, and it'll start on its own. So MLFlow also has a CLI for quick startup. So if you want just to use the terminal, you can use MLFlow's CLI to get started with changing things in the database, or adding experiment names, etc. And then it also features a low-level API called MLFlow.client, which has more advanced features. So their documentation on that is amazing, but we're not going to go into it. And the last thing is that it supports a ton of different machine learning frameworks. So PyTorch and TensorFlow are the big ones, but then it's also recently started supporting other LLM-based frameworks. So that is really useful. So this presentation is about 3 specific gems that I wanted to talk about in relation to MLFlow. And I found these gems through a specific project that went terribly. I learned that there are 3 functionalities that I would not forego on the next project, and I wanted to share them through this story of a fake project called Project Llama that is based on a real story about a client project. So with this project, we were asked to build a machine learning model based on radar data, and we started it like we started any other project, which is cleaning the data and preparing the data pipeline. And then we got to the exciting part, which is exploring the different algorithms that we might want to use to build the AI application. And it was really exciting to use MLFlow because we'd used it a few times, but this project was really big. And we ended up seeing that a lot of our log lines for MLFlow were bloating our code base. So with MLFlow, when you want to log a parameter or a metric, you can basically put a line like one of these, right, to log an individual parameter. But as your code base grows, you start having these chunks of log lines all across your database, and it gets kind of messy to read. So that's when we discovered the first hidden gem that I'm going to talk about today, which is MLFlow's Autolog feature. So in your Python, you can drop this MLFlow.autolog, and it'll automatically detect the machine learning framework that you're using and track all of the parameters and metrics specific to that framework. So you don't have to go and remember what it is or add it later and have missing data from previous runs. So that's really useful because it means less technical debt later on, because you don't have to figure out if there's like dead logging lines and stuff like that. And it also gives you more consistent and thorough logging because it'll just log everything from run 1 if you use it from the beginning. So that really helped us keep better track of our metrics and our parameters. And we started getting into the development of a specific, more refined model where we had felt like we locked down the algorithm behind it, and we wanted to do some feature testing. So the client wasn't really sure if we'd actually be able to come up with an AI that would solve this problem. And one of our team members ended up finding a model that really worked and had really good performance metrics, which was really, really great. Until the client wanted us to reproduce those results on the same week that that team member left for a different project. So machine learning projects are super quick and have like a lot of experimental code within them. And it can be really hard to align your machine learning metrics with the actual code that was used. So our team spent 4 days just trying to piece together the code base in order to somehow reproduce the metrics that the client was really impressed by. It kind of felt like searching for a needle in a haystack. And while we eventually got there, we realized there had to be a different way. And that's when we looked into MLFlow's documentation, and it turns out they don't just track your machine learning metrics, but they also have a way to align your code with the metrics in order to help reproducibility. And that brings us to our second gem, which is MLFlow's git commit hash logging. So I found this particular feature really useful because this is again the Python code that you would put into your MLFlow project, but all it does is it detects what the git commit hash is that is related to the run that you executed on your AI application, and it will log it in the database and show it in the UI as a tag. So this provides a one-to-one mapping between the git commit hash and the run ID. So as you can see here, all of the git commit hashes are the same, and we're going to talk about a way to actually improve this feature to make it absolutely reproducible rather than, kind of what we see here. But the idea is that there is a way to map your code with the version of your metrics. And that helps other developers on your team add to your model and helps your clients understand that they can actually reproduce it themselves. All they would need to do is check out that commit, and they could see the results. So it allows for your code and your metric to be aligned, and that way you aren't spending 4 days trying to piece together the code base, but instead 4 days actually improving the model. So eventually we landed on a model that we thought was exactly what the client would want, and we were ready to deploy the application, which is awesome, right? Like all you have to do is just like clean up a few things, and that's it. Well, packaging machine learning applications is rarely that easy and simple, and it turned out that way for this project as well. We had to somehow figure out how to make sure that we've deployed only the code that was actually used, along with the right version of data, and our machine learning metrics actually had grown quite a bit over the duration of this 9-month project. We now had thousands of runs that we had to somehow gather together to present to the client and explain the story of how we got there, since this project had been deemed to be quite difficult to begin with. And they were really curious about the underlyings of the model. What we really needed was a way to organize the models from all of the experimental code and all of the experiment trials that we had run over the 9 months. And MLFlow gives another organization method that we started using for this project, which is their model registry. So you can use this line of code in your Python, as well as the parameters that link to the run ID that is used for the model you want to later deploy and track, as well as give a name to the model itself or the version of the model. So this takes you from your models just being metrics and rows within that UI to now being separated into an understandable format where you could then talk to a client and say, hey, this is version 2, this is how we got to this conclusion, this is how we got to this model, and here are further developments that we are thinking of. So this organization helps make your models actually more searchable over time and allows you to then link back to the details behind how you got to the final product, allowing you to actually explore the different metrics and the parameters, as well as maybe some of the other models that led you to that conclusion along the way. So like I said, it helps with searchability, and it definitely helps when you're coming up with your final documentation, as you can kind of paint a story from how you got from the start to the end. So these 3 hidden gems saved us a lot of development time, and it also gave our team more confidence in our own metrics that we were presenting. But most of all, it instilled trust within our process, within our clients, since they understood a lot more of what was going on with the AI that they were now being handed, and could hand it to their own development team with documentation and metrics that helped them work more and build upon that AI. So there's 2 additional tips that I wanted to leave you all with. And the first one may seem kind of obvious, but it is to back up your data. So I know that that one always gets some concerned laughs, but on this project, we learned that in machine learning, there's more than just input data. Your data that you are collecting with regards to your metrics is just as important as the data that's going in to train the model itself. And we've only realized that when 25% of the way into the project, one of our developers accidentally deleted the MLFlow database that contained all of the information related to the metrics and the parameters that went into all of the trial runs. So that meant that we didn't have anything to show the client for the demo that day, and that meant that we had no information for what to iterate and improve on, besides trying to, again, look at the code base, which at that time was in flux. So backing up your data is something I would absolutely recommend, even though it may seem trivial at the beginning. The second one is to commit frequently. So earlier we saw with the second hidden gem that you can store your git commit hash within your MLFlow database in order to make your model reproducible later on. But it's only helpful if you are committing your changes to your model frequently and at the time that you're executing an MLFlow run. So what our team ended up doing was creating a branch that we knew was going to be highly experimental and contained a lot of commits that are related to very minute changes. And we had a warning so that every time we were going to kick off an MLFlow run, we ensured that the developer knew to commit. So that way the commits were truly a snapshot of the model code at the time of the experiment being kicked off by MLFlow. So those are the 2 tips and the 3 hidden gems. And the overall takeaway message is that Trust is the most important thing that we can sell in today's AI applications. And while MLFlow itself is super exciting and super cool, understanding why we're using it and how to use it is also just as valuable. So if you want to learn how to integrate MLFlow into your code base, then I would take a picture or write down the first link. That is a GitHub repo that contains the MLFlow within like an active ML application that I've created as a sample for all of you. And the second is my website, and the third is my work. But we actually do have time, so if there's any questions, then please let me know. And thank you for coming.
If you have, okay, well, I'll bring the microphone to Lynn.
Thank you. Thank you so much for your talk. I appreciate it. Just out of curiosity, I mean, MLFlow is pretty awesome. I've used it myself. What cons do you think MLFlow has, or what do you wish it had?
That's a great question. So the main thing that I think would be helpful is more visualizations. So for those of you who haven't used MLFlow, it does have a way to compare different experiment runs and see the visualizations of the parameters or metrics changing run over run. But there are other metrics under the hood that really help machine learning engineers, like CPU utilization, GPU, all of that stuff. And I know that the other popular tool for this kind of metric tracking, weights and biases, has those features. So that's really awesome. So that's the main thing I wish, but since it's open source, I understand. Thank you for the question.
Krishi, thank you so much for your talk. In the experiment tracking, like you showed us up on the screen, do those experiments also track variations in the feature engineering pipelines? We know that those might change run to run, model to model. Is there tracking for that part of the overall workflow too?
Anywhere you add the logging, it'll log that parameter or metric. So if it's something that, right, with autologging, we talked about how it can detect the machine learning framework and automatically start tracking those. If it's something custom, you can add your own custom, like I want to track this feature. Maybe it's a label or some variable that you've created that is unique and not part of that framework. You can track that and add that as your own customized log line. So does that help?
Yes, thank you.
Thank you for the talk. I really learned a lot. I am the only data scientist on my team and still early in my career, so I didn't know about MLFlow. So this seems really helpful. I am just curious, since you seem very experienced with it, is there a way to do it totally locally? Because at my company, I have problems sometimes convincing the company to give me resources. So can I totally run it locally with my own computer? And is there any drawbacks or things I should be aware of doing that?
Yes, you can definitely run it locally. I've honestly run it locally many times just to experiment with new releases and stuff like that. So in terms of drawbacks, I mean, again, besides some of the cons being that there aren't a ton of features, I haven't had that issue, but I would say the main thing I would watch out for is, again, to make sure that you've somehow backed up your database, because when it's local, right, if there's no cloud object versioning or object lock or something, that was actually how it got deleted. So that's something I would watch out for.
All right, thank you.
Hey, thanks for the talk. Actually, in terms of backing up the database, is that something you'd recommend putting into a Git repository?
Good question. I think that I don't remember the database ever getting too big, but I still would probably back it up in the cloud or something like that. We didn't back it up in the Git repository. It doesn't have sensitive data, but one of our projects, we did end up logging something custom. So some patient images, and those couldn't go in the Git repository, so we stored them behind private S3. So it totally depends on your situation, how long the project is, how big you expect the experiment logging to get. But yeah, I mean, you could, but I haven't done that before.
Got it. And good point on the custom logging.
Hi, thanks for the talk. Just a quick question. I'm sure if you are familiar with the file type that the model registry is using under the hood. Like, is it like a binary file, or how is that? How are they storing the trained models? Thanks.
Okay, yeah. So they are storing, honestly, I think I'd have to look into that to make sure I get the right answer. So I'll get back to you.
Guess I have one question, so I'm going to take this opportunity. You mentioned that one of the best practices is to commit frequently, and then I might have lost it because I don't have it in my notes, but you said about something about like if you added a warning in your, I guess your MLFlow environment, so if you don't have a commit. Is that part of the UI, or is that like a pre-commit hook? How do you
Good
did
question.
that? Yeah.
Good question. So it was a pre-commit hook, and actually going back to a previous question, that's probably something I'd love for MLFlow to just have, but I don't think it works that way. So we just did a pre-commit hook and tried to make sure that people were highly encouraged to do a quick commit before they actually executed the MLFlow run. So that's how we did it.
Any other questions? Okay, thank you so much, Krishi.
Thank you.